Hello everyone, I am Dattatranikam. Welcome you all on our channel eFunda for new day, new topic. And our today's topic is a continuation of a previous topic, that is in parts basic refinery processes. Part 26A is already completed and published on our channel. Now this is a continuation of that previous part, and we are presenting this today as a basic of refinery processes part 26A1. This will be continuation of a previous video, and if you are new to our channel, then please visit to our channel eFunda and watch all the videos created related to various topics, for which the playlist is created and published on our channel eFunda. And don't forget to subscribe to our channel and press bell icon to get the latest notification on upload of our new video on our channel eFunda. Also, eFunda team has created and started the membership option. What you have to do is just press the join button and get the membership. It comes with other benefits as well. The most important benefit is that first video will be notified to you and the rest will be followed after you. So let's begin with our today's topic, that is a refinery of a basic processes part 26A1. Reforming process. So far in our previous video we have seen that the basic introduction and related information about distillation, conversion, treatment, that is blending, and other details of the atmospheric distillation as well as the vacuum distillations. Now we are continuing with reforming process. Reforming is a process which uses heat, pressure, and a catalyst, usually containing platinum, to bring about the chemical reaction which upgrades naphthas into high octane petrol and a petrochemical feedstock. One can refer to the figure where you can see the complete process, where reforming is the another process in which hydrocarbon molecules are rearranged into other molecules, usually with the loss of a small molecule such as a hydrogen atom. The naphthas are hydrocarbon mixture containing many paraffins and naphthalase. One can refer to the catalyst. There you can see heptane is equals to toluene plus hydrogen. After the catalytic reaction, it is divided into C7H16 into C7H8 plus 4H2, that is hydrogen. Then cyclohexane C6H12 becomes benzene plus hydrogen, that is C6H6 plus 3H2. This is what the process is all about. And in many of the countries, this naphtha feedstock comes from the crude oil distillation or catalytic cracking processes, but some of the overseas countries, it also comes from the thermal cracking and hydrocracking processes. Reforming converts a portion of these compounds to isoparaffins and aromatics, which are used to blend higher octane petrol. The reforming process or a procedure reformate, which is needed to increase the octane from today's cleaner burning fuel. Most interestingly, the hydrogen is also produced by this catalytic reforming process. This hydrogen is then used in other refining processes such as hydrotreating. Paraffins are converted to isoparaffins. Paraffins are then converted to naphthalase. Naphthalase are converted to aromatics. And the complete process figure, one can see the naphtha is entered into the heater. Then whatever the naphtha is there, it is heated, and then its vapor is passed to the fixed bed reactor, and then further whatever the vaporization is there, that will be up, and the remaining part is passed to the second stage heater, then fixed bed reactor, then heater, again fixed bed reactor, and then finally the reach to the gas separator, where the hydrogen is removed separately and whatever the other parameters or gasolines are there that will pass to the stabilizer so as to get the settled residue, that is a reformant of benzene, toluene and xylene, and above the vapor forms are the methane, ethane, propane and butane are getting separated. This is all about the reforming processes. Cracking process. Cracking processes break down heavier hydrocarbon molecule, that is a high boiling point oils, into lighter products such as a petrol and a diesel. These processes include catalytic cracking, thermal cracking and hydrocracking. Let's understand by the example C10H22, that is a decane having the boiling point of 174 degrees Celsius. Then once the cracking procedure is applied, then it will reduce to or change to low boiling point, that is a 36 degrees Celsius, where C5H12, that is a pentane, and C5H10, that is pentene, are getting separated by this cracking process. Similarly, the for other example, one can see the catalyst, that is C16H34, that is hexadecane. After cracking, it is C8H18, that is octane, plus C8H16 is a 1 octane. And another example is a hexane into butane and ethane, that is C6H14 is getting converted into C4H10 and C2H4. This is how the cracking process help us to reduce or change hydrocarbon molecules of a high boiling point into the low boiling point. The continuous process of a cracking can be understood from the below figure, where the crude oil feed is coming to the cracking process, and the cracking process is further classified or divided into catalytic cracking, fluid catalytic cracking, thermal cracking and hydrocracking. These are the steps of the cracking process. We will see one by one in detail for our understanding. Catalytic cracking process. Catalytic cracking is used to convert heavy hydrocarbon fractions obtained by vacuum distillation into a mixture of a more useful product such as a petrol and a light fuel oil. One can refer to the picture where one can see the equipment, that is a cracker reactor, then the stripper and a catalytic regenerator are kept it there, where one can see how the steam and oil is entered from the bottom, and then the other at the stripper the steam is again passed through, and then further into the cracking reactor the reactions will be done on the product which are used, that is a catalytic, and then further once the cracking is done and then the product to fractionating column are passed, then the spent or remaining catalytics are passed back to the column again, and then further from the stripper as well into the catalytic regenerator, where mainly the air is being introduced into the spent catalyst, that is a stripped, and then further after reaction inside the catalytic regenerator the waste flue gas recover and then it pass to the further process. Similarly, the catalytic cracking is the most widely used process for converting high boiling point hydrocarbon into molecular compound boiling in the transportation fuel boiling range. This process of the feedstock undergoes a chemical breakdown under controlled heat of 450 to 500 degrees Celsius and a pressure. In the presence of a catalytics or a catalyst, a substance which help us to promote the reaction within itself being chemically change, small pellets of silica, alumina or silica magnesia have proved them to be the most effective catalytics used in this process. The cracking reaction yields petrol, LPG, unsaturated olefin compound, cracked gas oils, and a liquid residue called as the cycle oil, light gases, and a solid coke residue. Then the cycle oil is recycled to cause further breakdown, and the coke, which forms a layer of a catalyst, is removed by burning the fuel. The other products are passed through the fractionator to be separated and separately processed one by one. This is all about the catalytic cracking process, where catalysts are being used for this cracking process. Moving on to fluid catalytic cracking, that is FCC. FCC is a process that converts high boiling point, high molecular weight crude oil into various petroleum products such as gasoline, olefin acid, and many other. One can refer to the picture where the complete process is shown. Was introduced in 1942. This is an excellent integration of a reactor with a catalyst regenerator for high thermal efficiency. The FCC uses a catalyst in the form of a fine powder which flows like a liquid when agitated with the help of steam, air, or a vapor. When the feedstock entering into the processes then immediately meets a stream of a hot catalyst and vaporizes, and the feed is at the 300 degree Celsius Fahrenheit, then it passes to the reactor where the regenerated or catalyst from the regenerated mix at the reactor, and both are gets heated up to 1000 degree Fahrenheit, where the riser part are there, and upon the heating the vapors are produced, and those products are considered as a fluidized, and it passes, then it takes place where the hydrocarbon vapors then passes to the streaming section where the most of the volatile hydrocarbons are removed, and then it passes to the regenerator again. Before that, the products are sent to the fractionator where gas, gasoline, light cycle oil, high cycle oil, and decant oil is being produced as a subproduct of the petroleum product after the FCC process is done. Upon the catalysts are burned, then cooked catalysts are sent back to the regenerator and mixed with the air, and that is up to the 1300 to 1400 degree Fahrenheit heating is done. Then after burning these, then the flue gases are taken to the CO boiler type, and again the catalyst then flows back to the reactor. Then the catalyst thus undergoes the continuous circulation between the reactor stripping and regenerator section. This is how the FCC method is being used for cracking of the petroleum product into the various subproducts as we have seen just now. Thermal cracking. Thermal cracking uses heat to break down the residue from vacuum distillation. The lighter element produced from this process can be made into distillate fuel and petrol. The cracked gases are converted to the petrol blending component by alkaline polymerization. Naphtha is upgraded to high quality petrol by reforming. Gas oil can be used as a diesel fuel or can be converted by petrol by hydrocracking. The thermal catalytic cracking, one can refer to the picture. It started in 1942, that is a TCC, moving bed of the catalyst, then synthetic alumina or a silica beds, then integrated reactor generator to increase thermal efficiency. As you can see into the picture, the feed is entered and simultaneously the steam is also given, and then the products are sent back to the fractionator, and the catalyst particles are also added during the feed inlet stage. Then upon the processing, the hot air is again mixed with the burn coke catalyst, and then further is passed down to the bucket elevators, and so on. This process is going on. The heavy residue is then converted into the residual oil or coke, which is used to manufacture of electrode, graphites and carbides. This early method, which produced large amount of solid unwanted coke, has evolved into modern thermal cracking process, including vis breaking, coking and steam coking. For understanding better of a vis breaking, one can refer to the picture where preheat furnace, then soaker drum, that is optional, then the fractionator where the gas and LPG, gasoline, gas oil and tar is produced, then passed to the vacuum fractionator is also optional based on the process requirement it is passes. Then heavy gas oil and a vacuum flash tar are being removed. Vis breaking is an abbreviated term of the viscosity breaking or a viscosity lowering, a relatively mild liquid phase form of a thermal cracking. The main purpose of a vis breaking process is to produce a fuel with a lower viscosity than what the feed and a vacuum residue. This is what the vis breaking process is used during the thermal cracking. Thermal cracking by the method of delayed coking, one can refer to the picture where various components or equipments are being used. Feed is entered, then the particles or the equipments used are coke drum, furnace, fractionator, gas oil stripper. Once the feed is entered, then it pass to the coke drum and further it will pass through the furnace, and then it is passing it to the fractionator, where upon the method of the thermal cracking the process is being done, and then the products are being sent it to the separator, where the separation of the gas as well as the unstabilized naphtha is done at the stabilizer, and further then the residue is passed to the gas oil stripper, where the gas oil is being separated and the remaining part is again sent it back to the fractionator. This is how the process of coking is done. Coking is a severe form of a thermal cracking used to obtain straight run gasoline and various middle distillate fractions used as a catalytic cracking feedstock. This process so completely reduces hydrogen from hydrocarbon molecules that the residue is formed of a almost pure carbon called coke. This is how the delayed coking is used as one of the thermal cracking method, and the other method of the hydrocracking we will see as part of next video of our series. Today we are ending our second part of the series here, where we have seen what is the cracking process, then catalyst cracking, then FCC, then thermal cracking, and the next video will be covering for hydrocracking in the detail, where other parts of the isomerization, alkalization, polymerization and other processes will be taken care. Hope today's video will help you to understand the basic operation of refinery processes. With this, we are concluding on our today's topic. Thanks for watching our channel eFunda, where you will get to know the fundamentals. So that is our tagline, get your fundamentals right, where we do identify the needs, then we evaluate the need, then define plan for a particular need, and then accordingly execute the plan. This is what we are creating our technical videos, so that it will help every individual to get their fundamentals right. And if you are new to our channel, then subscribe to our channel, and don't forget to press bell icon to get the latest notification on upload of our new video on our channel eFunda. Also, you can follow us on our Instagram page, and do follow our Facebook page as well. So keep watching our channel eFunda for new day, new topic. Hello everyone, I am Dattatrenikam. Welcome you all on our channel eFunda for new day, new topic. And our today's topic is basic of a refinery process, part 26A. As mentioned earlier, this will be a series for process engineering, and we are going to cover today the basic of a refinery processes, where actually the refining is the process of reducing the impurities in a substance. You can't turn a crude oil into gasoline without first heating it, then refining. One can see, as our thumbnail shows, crude oil is entering to the furnace, and then at a different level of a heating you can get the various byproducts, which you can see as a picture as well. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created related to various topic, for which the separate playlists are created. You can just visit on our channel eFunda, and don't forget to subscribe to our channel and press bell icon to get the latest notification on upload of our new video on our channel eFunda. Also, eFunda team has created options for the member, those who are interested to learn more and get the fundamentals clear. Do press join button to get the membership of our eFunda channel community and get a lot of benefits. And one of them is the first you will get the notification or our video to you, and then it will pass to other viewers as well. And let's start with our today's topic, that is basics of a refinery processes, part 26a.